Hello students, once again you're welcome to Wisdom University. Today we're doing chapter 6, section 4, and the topic is IPv4 addressing. Okay, without much ado, let's begin. Now if you take a look at what we have, okay, let's take our highlighter as usual. Okay, if you take a look at what we have, you see that we have the different classes of IP address, IPv4. We have the different classes, and then we have the IP address range, the range of the address. So for class A, we have the range from 0.0.0.0 up to 126.225.225.225. So class A IP addresses ranges from this. Okay, you will be assigned dynamically IP address that covers this range. So this range of IP address is categorized or called class A IP addressing. Class A IP address, okay, version 4. Now for the class B, we have you see from here up to start from 128, right? Like 128 minus 2, which is 126.225.225.225. Okay, then the next one is starting from 128, okay, 128.0.0.0 up to 191.225.225.225. So this is for class B. For class C, we now start from 192. Okay, we start from 192. So 192 class C will be 192.0.0.0 all the way to 223.225.225.225. That's minus 2. You know, this one, the difference where this one stop and this one is a difference of 2. Then the next one, class C, we start from, okay, this is for class C. Class C, we start from 192.0.0.0 up to 223.225.225.225. Then class D starts from 224. You see, this one started from 1 and this one ends start from here 191. Then the next one here from 192, right? So this one stops here at 223. Then the next one here will begin with 224. 224.0.0.0 up to 239.225.225.225. So this is the class D range of the IP address, the range of class D for version 4 IP addressing. Then the next one, this one stops at 239. The next one will start from 240. So 240.0.0.0 up to 254.225.225.225. So this is class E. This one is categorized as class E for the IP address. Class E for the IP address. Is that okay? So you can see for version 4, IP address version 4, they are assigned like this: class A, class B, class C, class D, and class E. Each of it has a range of dynamic IP address that can be assigned to it. Is that okay? Now let's move on quickly. Now see for example, the decimal number of an IP address, for example, 10.10.20.1. So you can see the binary equivalent of each of them. So you can convert this to binary, you get this. Is that okay? Or you change this one back to decimal, you get 10. By saying 0 multiplied by, you know, I told you in the last class that this will be 2 to the power of 0. Okay, this is 2 to the power of 0. So 0 multiplied by 2 to the power of 0 plus this is 1 multiplied by 2 to the power of 1. 2 to the power of 1. This is 0 multiplied by 2 to the power of 2. 0 multiplied by 2 to the power of 2. Then this one is 1 multiplied by 2 to the power of 3. Okay, I can stop here because the rest are 0, 0, 0. So anything multiplied by 0 is 0. So you can see 2 to the power of 3 is 8. 8 times 1 is 8. So here I have 8. And then this one, 2 to the power of 2 is 4, but multiplied by 0 is 0. So we have 0 here. No point. So I can just say plus. Then 2 to the power of 1 is 2 times 1 is 2. So plus 2. There's 2 to the power of 0 is 1. 1 times 0 is 0. So you say 8 plus 2 is 10. That's how we got this 10. That's how we got this 10 in decimal form. So convert these binary digits to decimal. This one will, you can see this is same. 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0. See, 0, 0, 0, 0, 1, 0, 1, 0. So this is also 10. It's exactly the same as this one. Let's take a look at this. If you do this, this is 2 to the power of 0. The first one is 2 to the power of 0. This other one is 0 times 2 to the power of 1. This other one is 1 times 2 to the power of 2. Okay? 1 times 2 to the power of 2. This is 0 times 2 to the power of 0. So I may even skip it because it's going to give us 0 at the end of the day. Okay, 1 times 2 to the power of 3. Then this is 0 times 2 to the power of 3. That's this place. 0 times 2 to the power of 3. Then this one is 1 times 2 to the power of 4. To the power of 4. So let's evaluate. This one will be 0, 0, 0 because anything multiplied by 0 is 0. So you see this one, 2 to the power of 4 is 16. 16 multiplied by 1 is 16. So we write 60 here. Plus. This is 2 to the power of 3, which is 8. 2 to the power of 3 is 8. Multiplied by 0, it gives you 0. Then this is 2 to the power of 2, that's 4. 4 times 1, that's 4. Then this is 2 to the power of 1, which is 2 times 0 is 0. 2 to the power of 0 is 1 times 0 is 0. So we have 60 plus 4, which gives us 20. So you can see the decimal number is 20 for this IP address. Then this is just 1. This one means 2 to the power of 0. So 2 to the power of 0 is 1. 1 times 1 is 1. 2 to the power of 0 is 1. Then 1 multiplied by this one is 1. That's how we got 1 here for this IP address. Okay, so we see this is the 32 bits, the structure of the 32 bits IPv4 address, okay? In the octet format. Okay, let's move on. Now see example we just showed 10.10.20.1. These are their binary equivalent. So we say this is the structure of the 2-bit IP address. Is that okay? And let's move on quickly. Now the class A, the octet making up the network and the host portions of the IPv4 is shown for class A, class B, and class C. Now class A has let's say this is 2 to the power of 3, which is 8. Let's say this is 8. The host is 8. The network is 8, sorry. The network is 8 for class A. And the host is what? 8, 8, 8. That's 24 together. 8, 8, 8, 8. That's 24, right? So if you add the host together, we get 24. So the host for class A is 24. The host is 24. The network is 8. This is 8 and 8, which is 60. Network here is 8. Another 8 again for this network. So that's 60. Host is 8, 8, which is also 60. Host is 8, 8, which is also 60. So for network for class B, we have 60, 60. Then for class C, network is 8, 8, 8. That's 24. So if you draw from here up to here, you have, up to here, you have 24 for the network, and then you have 8 for host. You have 8 for host. Okay, that's the octet mapping. That's the octet mapping. Okay, for class A, class B, class C of the IP address. So this is what is displayed. What I was explaining. You can see the network bit is 8 here. For class A, network bits is 8. Okay, the host bit is 888. That's 24. So the network bit for class A IP address is 8. The host bit is 24. For class B, the network bit is 60 because it's 8 and 8. 8 plus 8 is 60. and the host is also 8 plus 8, which is 60. So you have, for class B IP address version 4, IP version 4 address, the class B is 60 bits for host, for network 60 bits for host. Then for class C, you can see 8 plus 8 plus 8 for network, which is 24. So we have 24 for network and we only have 8 for host. Is that okay? Now let's move on quickly. So if you take a look at this table 6.9, you see that the number of hosts IP address by class. Now number of host bits for class A, the host for class A, you can see the host is 24, 8 plus 8 plus 8, right, which is itemized here in this table. 8 plus 8 plus 8, that's 24. So the host bit is 24 for class A. So the host bit is 24 for class A. So which gives us this: if you raise 2 to the power of 24, 2 to the power of 24 minus 2, you get 60,777,240. Okay, so for class B, the host bit is 60. Remember, the network is 60, host is 16 for class B. So you have 16. 2 to the power of 60 to give you this one. If you subtract 2, you get this figure. Okay, then for class C, you have only 8 hosts. Only 8 hosts. See, for class C, you have only 8 hosts. The host bit is 8. So 2 to the power of 8, 2 to the power of 8 will be equal to 256. So minus 2, you get the number of hosts. Minus 2, you get the number of hosts for class C. So class C, you can host about 254. You can host 254 IP addresses. Is that okay? Okay, so that's that for this one. Let's move on quickly. Now let's go to another table 6.10, which is showing us private IP addresses. For private IP addresses, private IP addresses are not used on the internet. They have their own specific internal network called intranet. It's called intranet. They are not. They are blocked by the public internet. They are specifically used for specific internal organization. They are used by internal organization like the banking sector. They have their own network, not the internet per se. They have what they call the intranet. So they reserve these IP addresses for this private organization. So the class A for private IP address range from 10.0.0.0 up to 10.225.225.225. This is for class A, the IP address that is assigned. Okay. For class B, we are talking about the private address. For class B, it starts from 172.60.0.0, 172.60.0.0 up to 172.31.225.225.225. Is that okay? There, for class C, it ranges from 192.168.0.0 up to 168.225.225. So this is easy to comprehend, because this one for class C starts from 192.168.0.0. They are only assigning these ones up to 225.225.225. Is that okay? So we say the address ranges in class A, B, and C have been set aside for private use only, for companies, for private use only, not the public domain, not the public IP address. These addresses, they are called the private addresses, and they are not used for Ethernet data traffic, but they are intended to be used for what? For internal network called the intranet. They are used for internal network called what? The internet, called the internet. Internal network called the internet. Is that okay? Now let's move on quickly. You see, functionally, private addresses work the same as public address, except private addresses are not routed on the internet. That's just the difference. They work the same way as the public address, but except for the fact that they do not route them on the internet. So they are called, because you don't route them on the internet, they are called what? They are called non-routable IP address. Non-routable IP address, and are blocked by the internet service provider when they try to find their way through the internet. They blocked. Okay, now let's talk about the American registry organization that assigns IP address. So we got the IP address are assigned by ARIN. Okay, ARIN is simply stands for is an acronym. ARIN is an acronym which is America Registry for Internet Numbers. America Registry for Internet Numbers. This is the organizations that assign IP addresses to internet service providers and to end users who have large organizations. Now, if you want to know more about ARIN, you click their webpage, their domain, www.irin.net. This is their domain. Once you click it, you get more information regarding their job functions, what they do, how they do their job. Is that okay? Now, IRI assigned the IP address space to internet service provider and end user, but not just ordinary end user. They assign IP address to end users that are large enough to take a lot of the IP addresses. Okay, so they normally provide to internet service provider, and the end user must qualify, must have a very large network to take more of the IP address. So it requires that the internet service provider or the end user must be large enough to merit the block of addresses that this IRIN will assign to them. In the case where the blocks of addresses are allocated by IRIN to the internet service providers, then this internet service provider, they will issue address to their customers. So like Telco in US is an internet service provider. So this Telco now provide the IP address to every customer that needs a network, that's connected to a network. Okay, so that's how it works. But they can also give IP address to end user, like very large university, very big universities. Very big universities that take blocks of IP addresses, so they can get, and big companies, big corporations that are super large, huge. Okay, they can get these IP addresses. Is that okay? Okay, now let's move on quickly. So we say ID also assign end user. I think I have talked about this. Okay, we've talked about. So we say like big university and big organizations. So that's all we have for today. The things we've taken a look at is the IPv4, the different classes up to A to E, no routable IP addresses, the private IP addresses. Then we talked about IRI. So that's all we have for this section. Thank you very much for attending our class.